Hello everyone. This R project aims at performing EDA and predicting suicide rates. It uses country level suicide rate data from WHO and other country level indicators from the World Bank as well as the United Nations Development Programme from 1985 to 2016. The data contains information on suicide rates per 100k population with respect to population age, sex, generation, country gross domestic product GDP, population size and human development index country score. The data indicates its 12 variables for one target variable and 11 features. The target variable is the suicide rate, which is the suicide rate per 100k population. So we'll start with the data exploration. So what is data exploration? Exploratory data analysis is an approach to analyzing data sets to summarize their main characteristics, often with visual methods, that is graphs or other graphic pie charts and histograms, etc. So here we have first performed, we have shown the 6 rows of our data set and the values of all the rows. Similarly, we have next done the structure of the data set. So as you can see, all the values are given here with all the similar data types and the data over here. So the next thing we have done the summary of the suicide data set. In the summary, you can see the minimum, maximum, and medium, what are the null values, and everything is given in the summary. The next part, the next part is the data cleaning part. Here you can see first all the data types are given for each columns. As you can see, the factors, numeric values. So there are in total 2 numeric values. So that is the population and the suicide number are in our data set. So as you can see here, we have done the data cleaning where there was the value of the age column has extra string attached to a year string and white space on the left of the values. We will remove the both of them. And similarly, the 6 records of age after cleaning it are as follows. After this, we start with the plots. The first plot is the frequency table plot. Here, each entry in the table contains the frequency or count of the occurrences of values within a particular group or interval, and in this way, the table summarizes the distribution of values in the sample. In a frequency distribution, continuous scores falling within various ranges are tabulated. So here, the first graph we contain the population histogram, and the frequency is given. From this graph, we can see that the distribution of the population seems to be extremely positively skewed to the right with a spike at the first bin closest to the value 0. This shape suggests that the majority of the observation have a very small value of population with a small number of observation with very high values, causing a very long positive tail to the shape of distribution. Similarly, in the second graph, we can see the frequency table with respect to the suicide number. So here also we can see the same output where the distribution of the suicide rate variable seems to be extremely positive skew to the right and the spike is at the first pin closest to the value 0. The next part is explained by Smith.
This plot shows suicide rate histogram with frequency in the y-axis and suicide rate on x-axis. Even in this plot, the distribution of the suicide rate variable seems to be extremely positively skewed to the right, with a spike at the first bin closest to the value 0 and has the highest frequency. Next graph. This bar plot shows the number of males and females in the data set. We can see from the graph that the number of males and females are equal as per the data set. Next graph. This plot shows the distribution of generations. Generation X is in yellow and has the highest number of count, whereas Generation Z in green has the lowest. Next graph. Suicide rate varies from one country to another. This is confirmed by the following bar chart that shows suicide rate per 100k population against the countries. For easier interpretation, the figure below shows that the top 25 countries in terms of suicide rates. Lithuania is universally the top country in terms of suicide rate at a little over 40 suicides per 100k population. The rate is extremely high, especially that Lithuania is not a big country like Russia, whereas in Poland, the rate is quite low. Next graph. The next plot shows the suicide rate per 100K population against the continents in the data set. The distribution of suicide rates varies from a continent to another. The highest suicide rate are in Europe, and the distribution is severely skewed to the right. We see similar skewness in Asia and America, as well as with the presence of a few extreme values in each continent. Next graph. The next plot shows suicide rate variability by population size given in the data set. There seems to be sort of a positive linear association between the country population size and its corresponding suicide rate. Lithuania and the United States can be considered as two outliers in two opposite direction in the data. Presence of such extreme values affects the prediction process. Further will be explained by Sarvesh.
So in the next graph, we see the effect of nation wealth on suicide rates. In this plot, we can see suicide rates plotted against per capita GDP of the country in the data set. It seems that there is a positive linear correlation between suicide rates per 100K population and the country's GDP per capita. So there exists some outlier values in case of Lithuania, but they have a relatively small per capita GDP and have very high suicide rates. That is seen earlier as well. So in the next graph, the positive characteristic variability is seen. And now after taking an overview of the suicide variability by several country and nation level variables, we move to demographic values that characterize the populations of these countries. So first we look at the suicide variability by the age group. And in this box plot, we see the suicide rates distribution varies from one age group to another. The highest suicide rate is found between individuals aged 75 plus, and the lowest is found in individuals between 5 to 14. Next graph. In this graph, we see a bar graph. When looking at suicide rates by sex, the data shows that the suicide rate is more prevalent among males than females, with universal suicide rate of almost 21 versus 6 suicide rates per 100K population. So from the above exploratory data analysis performed, the main observations that we concluded are that Lithuania was found to have an extreme value for suicide rates per 100K population. And in the year 2016, it included the least number of observations, while the target variable suicide rate is severely positively skewed. And to perform the machine learning part and to predict the suicide rate variable, we use linear regression and random forest algorithm. So to predict the target variable suicide rate, the regression model is fitted that takes into account country, population, size, per capita GDP, year, sex and age groups, and they affect directly the target variable. After prediction, performance of these two models is evaluated. Since the target variable is far from normality, a transformation is considered in order to scale the distribution to symmetry. So the natural log transformation produces infinite values. Since suicide rate has 0 values, then the value 1 is to added to the variable prior to applying the natural log transformation. So the training and testing data sets are created, and the testing data set is 20% of the entire data set. And the training data set is 80%. A linear regression model is fitted using the trained data, using the LM function, and the random forest is used using the ranger package. So now to test the model, we use the predict function, and the testing of the performance of the model is given by the root mean square error value, RMSE value. After generating the model predictions, this RMSE value is calculated by comparing the model predictions against the true value of the suicide rates that are present in the test data set. So the model with the lowest RMSE in this case is random forest. So the random forest gives better prediction of the suicide rates rather than the linear regression model. Thank you.
Thank you.